This is the sixth video in an overview series of the first 3 chapters of the book From Quantity to Number, a first course in mathematics. From Quantity to Number is a book for parents and students interested in a discussion-based math program for their homeschool curriculum. For more information, see inletbooks.com. In this video, we are continuing our discussion on addition based in ideas from Chapter 3 that will help students to learn how to add numbers. There are several properties of addition worth noting because they help in learning to add easily. One is the fact that the order of addition does not change the value of addition. For example, 3 plus 5 equals 8, and also 5 plus 3 equals 8. This is easy to see if we understand addition as a counting of 8. 5 and 3 are 2 parts, summing to 8, and the total value does not change with the order of addition. This property might help students to add numbers where, if they are more familiar seeing one order rather than another, they can reorder the addition to the familiar order. And just keep this in mind, that the additions can be reordered, if that's helpful. For example, it's often easier to add a smaller number to a bigger number. So if you're working with an addition like 9 plus 36, it might be easier to think of this as 36 plus 9. This property applies for any pair of numbers, and we can express this idea by using letters to name numbers. In fact, this is a good little discussion for parents, teachers to bring up with their students. It's a good discussion place to point out and to begin pointing out the very powerful idea of abstraction, that we can use letters to name numbers, and this is a simple application of that. For example, by stating x plus y equals y plus x, we understand here that we mean for any 2 numbers, x and y, the value of the sum x plus y equals the value of the sum y plus x. Using letters as names for numbers here is a convenient way to describe this equality for all numbers. It comes up a lot in practice that we have more than 2 numbers to add. For example, let's say we want to add 2 plus 4 plus 6 plus 8. We can determine the value of this sum by adding pairs of numbers. 2 plus 4 equals 6. 6 plus 8 equals 14. And then 14 plus 6 equals 20. The sum of 2 plus 4 plus 6 plus 8 equals 20. 20 expresses in a single counting the sum of these 4 numbers. Notice that in 2 plus 4 plus 6 plus 8, we can, and it's often useful to look for a different ordering in the addition. Here we might recognize that 2 plus 8 equals 10, and that 10 is an easy number to work with, so it's often worth looking for. Also, 4 plus 6 equals 10, and then 10 plus 10 equals 20. Notice also that if we're writing the addition, parentheses are convenient for grouping terms to show an order of work. Using parentheses in this way can make it easier to reread your work. And this, again, is a good little discussion topic in this space where you're adding more than 2 numbers together to talk about structuring a calculation when you're writing it out and using parentheses to help you structure that calculation. So these are the kind of little look-ahead ideas that you can introduce into discussions even at an early stage to start stoking these useful ideas coming up in subsequent discussions. One way to think about addition is in how it changes a number, or as a transformation of a number. In this perspective, one number is remarkable because it affects no change. This is 0, an addition by 0. For example, 8 plus 0 equals 8, and 0 plus 12 equals 12. This is easy, but it's easy on its own, it's easy individually, but it's worth calling out for students because it will be necessary to be completely fluent with this idea in the context of longer additions. And so when we change to that context and there are other things going on, it might be less readily apparent or upfront. So it's good really to call it out beforehand. With these elements in place for addition, and when your student is comfortable with all of these elements through practice, it's straightforward to step into adding bigger numbers. For this, we start with the understanding developed in Chapter 1. What are numbers? That is, numbers are lists of digits counting the powers of 10. For example, let's add 37 plus 15. 37 counts 3 tens and 7 ones. We can write this as 30 plus 7. 15 counts 1 10 and 5 ones, and we can write this as 10 plus 5. We want to count all the tens in a single count. We have 3 tens from the 37, and then the 1 10 from the 15. That is, we have 4 tens. Likewise, we want to count all the ones in a single count. We have the 7 ones from the 37, and we have the 5 ones from the 15. 7 plus 5 equals 12. 12 means 1 10 and 2 ones. We discussed this in Chapter 1 in detail. And so here we have, from the 12 ones, 1 more 10 to add to our tens count. 4 tens plus 1 10 equals 5 tens. And we also have the 2 ones. So altogether, 5 tens plus 2 ones equals 52. Let's work through another addition. 23 plus 19 plus 48. As long as we keep track carefully of the counts for each power of 10, there are different ways to add bigger numbers. There's not only one way to add numbers, and that's an important idea for students to understand. As the students are getting started, it might be easiest to work from the ones count to the counts for the bigger powers of 10, but you can also start by keeping track of the tens or the hundreds if that's the kind of number you're working with. Students might start with what comes most naturally, and then in their practice, they can look for multiple ways to add the numbers. This is also a good exercise to check answers. That is, looking for several different ways to compute the same addition or whatever calculation you're working on. So let's get back to this addition. Here we have 3 ones from 23, 9 ones from 19, and 8 ones from 48. We are thus adding 3 plus 9 plus 8. 9 plus 8 equals 17. 3 plus 17 equals 20. From adding the ones in our numbers, we have a total of 2 tens. We add these then to our tens count. So in total, our tens count is 2 from the 23, 1 from the 19, 4 from the 48, and 2 from the sum of the ones count. We determined 21s. 2 plus 1 plus 4 equals 7, and 2 plus 7 equals 9, so we have 9 tens, and that's 90. You could reach the same result, of course, by adding the tens counts first, and then by adding the ones. The key idea is simply to keep track of the counts for each power of 10. For the student who has a good understanding of the meaning of a number, namely that the digits count powers of 10, as we discussed in Chapter 1, this will be straightforward.